Let's see how to create a repository on GitLab and have two different users clone it so they can work collaboratively. So in this demonstration, the user on the left is Abe at Nimbus, and the user on the right is A Smith at GData1. These are two different users on different computers, and I want them to access the same repository. So I'm going to open a browser and go to gitlab.com, and I'm actually already logged in as this user, which is going to correspond with Abe at Nimbus. That user is going to create a new project. Let's call it my merge example for a future use video, and I'm going to create this project. So this is now someone's a naked project, right? So it's got a repository that's got nothing in it. So if I look at the files, there's nothing in the files. If I look at the history, there's nothing in the history. But I can start putting things in it by cloning it. So you take this address and the SSH. There are two different protocols you can use. You'll use SSH. And I'm going to clone this on my user on the left-hand side of the screen. All right, so now I have a directory called my merge example. And this user can edit it. Say, let's make a README file. Hello. This is a README for my awesome project. So now if I do git status, it shows me that I'm on the master branch. I've only done the initial commit, so it's essentially empty. And there's a new file which is untracked. So I'm going to add that to my repository. Now if I look at status, I have an added file. I'm going to commit it. You can say git commit, and it will launch a little editor to ask you to make a message. So this message should tell a future user why I did this commit. This was the initial commit. The colorization that's happening, by the way, is just to tell you that you should keep your messages short. So people like short commit messages so they can quickly browse through them. So now I can push those changes. See, what it's doing here is it's using SSH. I'm assuming you already have SSH keys set up. It's pushing those changes up to GitLab. And now if I look at my project, suddenly it's got a README file here in its list of files. And if I look at the history, there's a single commit in the history. In fact, let me look at this graph. I'll use the graph quite a lot. So here's a graph showing the number of commits. And here's the commit message. Okay. Now, suppose I've got a collaborator who wants to work on this project. I have to add that collaborator to the project. So I'm going to go to Settings and Members. I'm going to add a user, which will be this user right here is the one I want to use. And I'm going to also make that a master, actually. So masters have full access to everything in the repository, which if you trust your colleagues is often good, but if you're having a very wide team dispersed geographically, maybe it's not so good. For this example, they're both me, of course, so I trust myself to be master. So there are two users here. The original one, marked as Abraham David Smith right there, and the other one, Abraham Smith GDA, wearing a mask, and that one, the evil twin of the first one. So let's suppose this window on the right corresponds with that new user. So this user on GitLab has already uploaded his SSH key, and he can clone the repository. So in his web browser, which is this one, if he looks at his project list, the project now shows up in that list. So he can take the address and he can clone it. So now the user on the right-hand side of the screen has access to the repository and can make changes. So he cloned it and can make changes. Okay, so what happens here is a standard process where a user will pull, a user will work, whatever that means. The user will commit, and the user will push. And so that process of pull, commit, push, push, that works very well as long as a single user is working on a project. What I want to demonstrate next is what happens if each of these users makes changes at the same time and isn't aware of the other one's work, and how we resolve that problem. So currently, if each of these users runs git pull, they're both told that they are up to date. So they're like, okay, let's start working. Okay, so the user on the left-hand side of the screen says, I need to fix that README file. I found a typo in it. Also, I'm going to make a new tech file for my documentation. Notice what I'm doing here is I made it a file, then I added it, and now I do status, and I see I have a new file and a modified file. I'm going to commit all files. I'm going to leave a message which is fix typo and made new document. Now this user is recently pulled, and they're going to do something else. They're going to edit the README file, and they're going to maybe say, for my awesome new project, they don't notice the old typo, but they also introduce a new line. This will be awesome. They examine their status. They commit the README file, so added some notes to the README. And I'm going to commit, the -a means commit everything that's pending to commit. Otherwise, you have to specify it file by file. So on each of their own computers, each user has committed a single file. And notice that some of those commits don't overlap. For instance, the first user made a new file that the second user didn't even know about. But they also have modifications that might overlap. So how do we resolve this? Well, let's suppose that by chance, this user on the right-hand side of the screen has pushed first. So now GitLab knows about the right-hand side's users' changes, and let's verify that by looking at the history. So if I look at the repository, and I look at the, let's look at the commit. These are the commits. See, and let's look at the graph, which is a nice way to represent it visually. So the user on the left-hand side of the screen committed first. This must tell a future user I went to this commit, and then the other one said add notes to the README. Okay, so now what's going to happen is the user on the left-hand side of the screen has done his work and he wants to push. And he's told this warning message, failed to push some references. Updates were rejected because the remote contains work that you do not have locally. And it helpfully tells you this is usually caused by another repository pushing to the same reference. You may want to first integrate the remote changes with git pull, etc. before pushing. And it tells you to look at the help file, of course. Okay, so he says, oh, someone else must have been working on this. Let me pull and see what's new. And notice what happened here. It pulled. And if we read through this line by line, okay, it brought in the objects. It kept track of what was happening. And it says auto-merging README. It tried to merge the README file automatically. But then it said conflict. Merge conflict in README. Automatic merge failed. Fix the conflicts and then commit the result. So it's telling us that we have to fix the conflicts. So how do we do that? Well, what we do is we run, we can say git diff. That shows us the differences, but we can also do git diff tool and or git merge tool. and this will launch meld. Okay, so what is going on here? We have 3 different windows, 3 different panes, okay? And notice how they're labeled. There's the local, which is the one I already had, the one where I fixed the typo of A. There's the one in the middle, which is what we're going to create as the new output. And there's the one on the right, which is the one that remote had sent us, the one that just appeared through the pull. So what we have to do is decide how to resolve these. So I'm going to say take this line, and I'm going to put it here. But also I'm going to take out that A. So now look at how it looks, right? When I did that, I did those changes manually, but now see what it looks like. Comparing to the local version that I had, hello, this is a README for my awesome project, that line is the same. Now, that version differs from the other one. Let's see, let's maybe be nice and put in that person's new comment. Right, so it says they're all different now, but you can see the differences character by character if you are a little careful about it. So we can bring in, say, their second line and their first line, and maybe let's do this. And now here we have a combined version, which I will save. And that version now is the one that will be in the repository. So I can close my merge. And let's see what happened here. If I do git diff or git status, it's telling me that I've modified the README file and also created this thing called readme.orig. So let's look at that file for a moment and see what it looks like. This essentially saved the thing that had to be resolved for future reference. So these things are sort of temporary files that, in case you want to quickly back up and undo something, you've got this to remember what had happened. Usually, if you did your merge reasonably, though, that isn't necessary. So actually, we'll just remove that file for now. That's going to be produced basically whenever a merge fails, an automatic merge fails. So now what I can do is I can now commit these changes. So manually merge changes to the README file, and I can now, let's say git merge. Sorry, I needed the -a there to commit all the changes. All right. So what I did here, despite my typo, is after doing a manual merge, I said, let's commit all those changes with the comment manually merge changes, and then notice there's no more merge to happen. And so if I do git status, everything's up to date. Let's push. And now the push is successful. If we look up at GitLab and look at the graph, look at what the graph looks like. There was the initial commit, the user on the left made a change, the user on the right made a change, and then the user on the left has combined those changes, and now the head version, the master version, is now combined. So if this user pulls, they see changes. There's a small change to the README file, and also this new document appears. And both users are up to date. If I could spell, anyway. So by defining your merge tool to be a graphical tool, you can take the mystery out of this merging process. It'll show you the two versions, and you decide how to combine them. If there are many files that conflict, it'll let you go through them one by one, or just replace the files in bulk if you know that one version is better. Basically, you get to decide. One thing to note that I didn't highlight at first is that the document.txt wasn't even dealt with in some sense, and it was automatic, because only one of the two commits had that in it, and so there was no conflict. You only have to do merging manually. if the changes are overlapping in such a way that the computer can't figure out what to do. So if, for instance, you're working on two different files, then just running the command git merge with no options at all will handle it automatically. In fact, let me scroll back here a ways. Let's remember what happened, why we had to run git. So the push had failed, and then I pulled, and then we ran git diff and git merge. So at this step right here, if those changes didn't overlap, if they weren't in the same line, then this would have worked with an automatic merge, and you could have just committed and pushed back, and there would have been no trouble at all. So you have to deal with things manually if the changes overlap. Again, the way to make sure this is going to work out is to look at your .git config file and make sure you have a merge tool defined.